Let's do a quick problem about spheres. The book has a good short introduction to spheres and why the equation of a sphere is what it is, based on the three-dimensional distance formula. The simplest example is going to be the unit sphere, x squared plus y squared plus z squared equals 1, and that's just exactly all the points with distance 1 from the origin. Then let's do a quick problem. This is problem 12. It asks, find an equation of the sphere with center 2, minus 6, 4, and radius 5. And then also describe its intersection with each of the coordinate planes. And describe is a little bit of a vague word. I'll make that a little bit more precise in a second. Well, this is just going to be all the points where the distance from our point xyz to the point 2, minus 6, 4 is equal to 5. Or, in other words, the square root of, we take the difference between the x values, x minus 2, and square it, and the difference between the y values, y plus 6, and square it, and the difference between the z values, z minus 4, and square it, and that's equal to 5. Or it's really usually nicer to square both sides of that thing. Let's just copy and paste, and just delete the square root and put a 2 there. And so that's a standard form for the equation of a circle. Now, again, the book has a good little short justification as to why this is the correct distance formula in 3 dimensions. It's really nice that it's not totally different from the 2-dimensional formula. And in fact, in n dimensions, it's just exactly the analog of this, where you just keep adding terms. So there's our equation. It's really pretty plug and chug. It's a pretty simple thing. What about the intersection with each coordinate plane? Well, I happen to have already plotted this sphere, and let's look at it dynamically. If we rotate it around, then it looks like it has an intersection with the plane. Let's see. It's hard to tell which coordinates those are. I think that's the YZ plane, yeah. It doesn't seem to have an intersection with the XZ plane. Remember, Z is up here in this picture. And it has a small intersection with the XY plane. And what do those intersections look like? Well, they look like they're going to be circles. And then we can confirm that algebraically. So let's do maybe 2 out of the 3 to save a little bit of time. Let's confirm that the intersection, that it doesn't intersect. In other words, the intersection with the XZ plane is empty? Question mark. Well, how do you intersect things? Well, as always, you just put a system of equations together. We want all the points that satisfy this equation, and also, I'll just put it right up here, and also we want to be in the XZ plane. Well, that's where y is equal to 0. Okay. Well, if y is equal to 0, then that becomes a 36. So I get x minus 2 squared plus 36, oops, plus z minus 4 squared equals 25. Can we see the problem with that? Yeah. We've got a sum of 2 squares. Let's move all the constants together on the right. We got a negative number over here. That's not going to be possible. So that's algebraically why it's not possible. Geometrically, I want to think a second, maybe pause the video. Why is this not possible? Why shouldn't it intersect with the plane y equals 0, the XZ plane? Well, how far is the center in terms of y? It's at minus 6. And how big is the radius? It's only 5. So if you can only go 5 units away from a point that has y coordinate minus 6, you're never going to reach y equals 0. Now, what about the intersection with the, let's say, the xy plane? Okay, so let me just copy the sphere equation. And then we also want z equals 0. Okay, so now I'll copy this one more time. This is now just 4 squared, which is 16. Oh, shoot, I copied the wrong one. Did you notice that? This is what I should have been copying. There we go. There we go. Now that's going to be an equation in x and y. That's going to describe some curve in the x and y plane. And now it's not just empty. It's not just impossible. Because over here we get 9. Oh, that's definitely a circle with the center being, surprise, surprise, 2 comma minus 6. That's just the projection of the center of the sphere. Let's see if the sphere will come back to me or not. Maybe not. Maybe it's just hosed. That's the projection of the center of the sphere onto the xy plane. X equals 2 and y equals minus 6. That's so that gives the center of that circle, and the radius. And radius is just 3. It's definitely going to be less than 5. And they've set it up so that it was nice. This didn't have to be a perfect square. They've set it up a little bit contrived so that things are like Pythagorean triples. Okay. So that's a very explicit version of describe, and I'd like you to do that. Either empty or it's a circle or whatever it is. You know, be more explicit than just I think it's a circle or something like that. Okay.